And we are live. Welcome everyone to Coatings Talk. When we talk about corrosion control, cathodic protection has always been there. It's steady, it's reliable, and it's quietly doing its job in the background. For decades, cathodic protection was treated like a supporting actor in the integrity world. Important, yes, but rarely the headline. But in 2026, that's different. We've hit a convergence point that the industry can't ignore anymore. Our infrastructure is aging faster than we can replace it. Regulatory pressures are tightening across pipelines, terminals, tanks, and utilities. And digital transformation also is becoming part of the equation. I'm talking about real digital transformation, not buzzwords. It's finally reshaping how we monitor, how we measure and maintain buried and submerged assets, but also above ground assets as well. And this is a year that cathodic protection stops being a background technology and it becomes a frontline integrity system because the stakes have changed, the expectations have changed, and the tools, data, and risks surrounding cathodic protection have changed. We're seeing more scrutiny from regulatories, we're more demand for defensible data, and more pressures on operators to prove, not just assume, that their cathodic protection systems are performing the way they should. And in the workforce with turnover, AC interference challenges, hybrid CP designs, and the rise of remote monitoring, and suddenly cathodic protection isn't a set it, forget it discipline anymore. It's a strategic asset. And that's exactly why today's conversation matters. Joining me is someone who's been at the center of this evolution, Raath from CathTect USA. Aaron brings a deep field of experience, global perspective, and a front row view of how cathodic protection technology, technician workflows, and integrity expectations are shifting in real time. We're going to break down what's changing, why it matters, and what operators, technicians, and integrity teams need to be paying attention to right now, not 5 years from now. Before we dive in, I want to hear from you, those that are watching this right now. Please post in the comments, what's the biggest cathodic protection challenge that you're seeing in your operation or this region this year? So drop that in the comments. Your insights will help shape where we take this discussion. So this is the state of cathodic protection in 2026. Aaron, welcome.
Yeah, thank you, Jim. I really appreciate the opportunity. I appreciate this discussion, and I think it's really a hot and an impressive topic. Again, for me being on this and having the opportunity for me is a hot one. And I say that because, I've been in the industry now 20 years, giving me enough credibility and experience to have tested the waters, seen what historically we've been doing. And I also find myself at this sort of I don't want to say middle-aged, but, still in a young and fresh perspective, saying that there's a long future and a long journey ahead for somebody like me in the industry that's building a career, building a business, and wanting to see how we shape that legacy of going forward, So I've inherited and built on this foundation of experience, but really where we're going, that's what's exciting. And I really want to reiterate what you're saying is we do have aging infrastructure. There's more infrastructure now than there ever has been in the history of the world. And what are we going to do with this? And I'm very excited to have been introduced to the cathodic protection industry. And so it's really about how do we maintain these assets for the future, for our children, for future generations. And so it's a fantastic topic, and I really appreciate you bringing me onto the conversation.
Yeah, I'm so happy to have you on because in May, we both participated very actively with the Appalachian Underground Corrosion Short Courses in Morgantown, West Virginia. And we had a very great conversation. We talked about things related to reconductoring. We also talked about the state of both cathodic protection and protective coatings. And as I had mentioned to you, and we were just talking before the stream launch about, one of the goals that I have related to Coatings Talk, even though coatings is in the name of the series, is that think of what's the industry. You have one side of a coin that's cathodic protection. The other side of the coin is protective coatings, and they need to work together. They're one thing together, but they need to work together, right? And so part of my idea is to try to bridge the two communities because we really do need to be connected. We also need to work together hand in hand because of what the future is bringing, not only in reconductoring, but all the demands that are out there regarding infrastructure and pushing things to last longer. And there's different ways to deal with corrosion. And sometimes coating's an answer, sometimes cathodic protection is an answer. And more often, it seems like the combination of the both working in collaboration is the answer. So let's open up this live stream and talk about the big picture. What's currently driving the change in cathodic protection today? And we're going to talk about 4 different areas, and I definitely want your input on this, Aaron. The first one is the infrastructure age curve. We have aging assets out there, from pipelines, from above ground storage tanks to terminals. We have all different type of infrastructure out there that is really critical. And a lot of them, and give you a good example, for like, you have a lot of critical infrastructure when it comes to the transportation system. It's hit critical life cycle points. And a lot of these systems were never really designed to go on to be 100 years and then want to be pushed even further beyond that. A lot of times the design life cycle was a lot shorter than that, and then they would be basically replaced with a newer system, a newer part of infrastructure. You yourself, you work out in the field. What is your current opinion when it comes to infrastructure and that age curve that we're currently seeing, not only here in the States, North America, and globally as well?
Yeah, no, it's a great question, Jim. And what I'm seeing is that we're doing a lot of projects where there's capital investment up front, but nobody's asking significant questions, or typically we're not asking the questions about what's the ongoing maintenance, what's the design life, and even if there's the design life, what are the increments of maintenance and who will pick these up at what point? So there's a lack of communication on future planning of this infrastructure. And so I'm trying really hard to push for, okay, so once the project's complete, what's next? And asking those questions, because you have people changing in their positions of employment with companies, different changes in ownership within the companies, and so it's very difficult to track these projects and this infrastructure over time. And I think that the way I'm seeing our approach to the industry is to say, as the corrosion specialist or solution providing company, we need to be on the forefront of knowing what are the projects that we've had our hand in, and what is the design life, what is the risk implications on the asset owner in the future if they're not aware of ongoing maintenance, corrosion risks, corrosion exposure. And I do want to bring us back slightly to what you said earlier about the collaboration between the coatings industry, the cathodic protection industry, and then not only that, but other utilities like the power lines, and other infrastructure, because we're now sharing common right-of-ways, buried infrastructure, and we do have influence on each other, one way or the other, good or bad. It is what it is. And so I think there needs to be a lot more collaboration. I think that's the way forward, is bringing coatings industry in line with cathodic protection, those working hand in hand. And then also, to your point on the question, is how does that affect aging infrastructure? How does that affect the asset owners? And how do we have a more collaborative conversation around these points?
Very good points. Another big driver is the regulatory pressure. I am a member and also on pipeline safety committee with the GPA, and we deal with a lot of the issues associated to on pipeline in the relationship with the regulations that are out there, and we're seeing an increase in a lot of reinterpretation, a lot of changes happening, not only in pipeline, but also environmental changes that are happening, even state level enforcement that's happening. And we're seeing also increase in audits that are happening out there that are driven by certain mandates and regulations and things like that. Cathodic protection, in your experience over the last couple of years, how has increases, or let's say, has there been regulatory pressures that have been impacting the cathodic protection industry, Aaron?
Yeah, definitely, Jim. I think that the regulatory pressures are definitely being felt and seen in the US, more specifically. I live in the state of Florida, and since we had the condo collapse, for argument's sake, it's highly impacted the corrosion in concrete structures throughout Florida, and it changed regulations within that sphere. that's only one example. You see that further with PHMSA, across oil and gas pipelines and how they're going to be monitored. And so it's increasing the need for data monitoring, management of infrastructure that has risk elements to society. And so those pressures are increasing from a regulatory framework. I think that the regulatory bodies are seeing that aging infrastructure, and they're trying to lead us down a road of maintenance and ongoing management of risk to our environments and to people. And I would say slightly different in my perspective internationally is that these regulatory sort of frameworks are different from country to country, but I definitely think that the awareness and the education levels worldwide are increasing. And because of that, I see other countries and other inquiries internationally sort of catching up in a certain way. Not in the same way as regulatory bodies sort of would enforce it, but people becoming more aware and then including corrosion protection or corrosion mitigation solutions in their awareness to these projects, to aging infrastructure. And I think more importantly, in a third world country kind of point of view, to new infrastructure that they're developing.
Yeah, it's a great point. And to your point related to regulations, and you're dealing, I'm up here in Pennsylvania. There's a lot of cross border with Canada, so you have to make sure that the complexities of two different countries and different regulations and rules that they have as well. Yeah. Earlier, you had mentioned, and this is another driver as well, and it's related to industry economics. Earlier, you had mentioned about projects, and I do agree with this aspect of it. We get opportunities to write specifications, bid on projects, chase projects, work with projects with owners out there. And it's focused on, let's say, if it's new construction, the aspect only of the new construction. There's really nothing that goes beyond that of ongoing maintenance and then also to future rehab schedules and things like that. It just seems like right now, and, AMP had put out, two variations of the cost of corrosion studies, the impact studies. And for whatever reason, I really scratch my head a lot where we talk a lot about, new projects, but a lot of times with a lot of our contacts out there that we're working on with the asset owner side, it seems like wait until there's their head's on fire and there's an emergency. And then we have to deal with it. We have to run around like chickens with our heads cut off. Yeah. Just seems to be a lot of proactive aspect of it. Why? Is it just about money, or what do you think is causing all that?
Yeah, well, economics always going to be the probably the highest driver of what we do and how we do it, right? And people that don't have the awareness, or if there's a situation where we don't have an economic driver, then we're going to sit in a problem. So I think there's a study that went out that corrosion affects more than $1 trillion per year annually worldwide. And in that, the cost of putting on a coating or the cost of cathodic protection is less than 1% of the replacement cost of an asset. So ultimately, the driver should be having the corrosion mitigation practices, which is going to cost you, if it's only 1% of the entire asset structure, it's a no-brainer. And I think the thing for me is that we need to have more of a voice out there to have that as the value proposition that we put out to either the operators, asset owners, or when we're bidding projects. When you put it in perspective to say, well, why should I spend money on corrosion protection? Because we've always done it this way, or historically it's been a certain way. There is a price point, but the advantages with technology, the advantages with the adaptation and more maintenance allows those structures to push on. So I do think economics is a very, very big driver. But what we're looking to do at CathTect is to essentially push what is the value add that we bring to the market. So just a very quick example of a conversation I had with a customer today was they've always used a coal tar epoxy. And it's saying, well, what are the new products on the market that are an upgrade that's going to extend life, or that's going to work better in a saltwater environment? And then reviewing that. But the angle that I'm coming from is cathodic protection. And so ultimately, we're having the conversation about what is the selected coating, what is the cathodic protection approach, marrying these together, and it's on a structure that's looking for a 100-year design life. Neither of these products that we're going to put out are going to have maybe a 100-year design life, but how do we make this asset with the best solution possible? And so my experience has been very much diverse from being projecting out in the field. I've done a lot of field surveys and coatings, but I've also been involved in product manufacturing. And so as that as the background, I feel like I have a very good solutioneering aspect of how I approach the market and the industry. And because of that, I'm trying to say, well, what's the best solution? And then ultimately bring in this economic factor to say, well, here's the driving pressures on cost, but let's look at the value that this is going to bring to the actual goal. And the goal is to protect that infrastructure for an extended period of time.
Yeah, I usually I bring this up from time to time because I learned a long time ago working on projects, especially when you work as in the aspect of a coating manufacturer, you're trying to get your products into a project. A lot of times you have the buying representative. Let's say you have the director of purchasing in a company. The director of engineer wants your solution because it's fit to purpose and it really is light years ahead of anything else as an option. And then you have, but there is an alternative. Let's say that the director of purchasing has his team, and you get a commodity buyer, and then they buy something completely opposite of what was in the spec and what the engineer want. And they're compensated on saving the company money, but they really don't really explore why does engineering want a certain particular product in this project. So there's a lot of different things, to your point, that really cause the economic issue to become front and center. Yeah. Another driver, and this is the last driver I'm going to cover because I think this one's also a big impactor, is the workforce shifts. And what I mean by that is there is a shortage of the workers that are coming in. The next generation, in coatings especially, we're struggling very hard, and I do see elements of that in cathodic protection as well. When we need technicians out there, especially when we have big things on the horizon, the reconductoring as it continues to roll out and changes within the regulatory frameworks, and also extending beyond what was normal design life to try to get that 100-year plus type of use out of critical assets, we need more technicians out there. Another area too is related to some of the training gaps that do exist. And also, we're seeing more of an encroachment of digital transformation where you have a lot of smart devices, you have a lot of different intelligent systems out there that can be above and beyond a remote monitoring unit. What have you seen regarding the workforce challenges that are in cathodic protection?
Yeah. And I think that's one of the biggest drivers to the state of cathodic protection in 2026, because for me, the workforce are the people that drive the industry. And so what I'm seeing is we have experienced technicians that have built the industry to this point, but they're nearing retirement age or beyond retirement age. And so their legacy has almost come to a certain season. And I say that on the back of, I've just found out of two people that I have always looked up to in our industry, passing within this past week. And so, it becomes very difficult, when these sort of industry giants, as I would put them, are moving on. And then at the same time, you have these younger technicians that are extremely comfortable in AC environments and, behind a desk and a computer. They know digital technology very well, but they still need to develop the troubleshooting skills that only experience provides. And so, like I said, that's why I feel like I'm at this sort of sweet spot between experience and digital technology. But at the same token, these younger people have to be the wave that's going to drive data collection, drive the monitoring, drive the way that we move as an industry. But it still comes on that backbone of the experience that we've built the US foundation on. And so that transition is a very interesting one. I think obviously with the talk of AI, how does AI fit into cathodic protection and corrosion solutions? And there's a lot of ways that can be leveraged, but there's always going to be this practical approach that has to be done in the field. And that's the sweet spot right now that we're in, that I think the state of cathodic protection is going to largely depend on how do we get that experience, but how do we step up the technology level? Because in many ways, we've sat for some technologies in the cathodic protection space for 30, 40 years plus, when there are innovative technologies that can be easily adopted, that are ready for market. And it's really saying, if I have an application, how do I up the game, improve the performance, because these solutions are in the market space.
Yeah, let's talk about the technology shifts that are reshaping cathodic protection in 2026 and beyond. To your point regarding digital equipment out there and a lot of it AI and advanced technologies, we do see the rise that should be happening when we talk about digital rectifiers, smart rectifiers, and also too remote monitoring as well, because real-time data is very, very important. It's very good, especially if it's being fed into an AI system that can do predictive analytics, um, automated alerts. When you have a lot of the real-time data and you have alert systems that are looking for certain type of situations, that could really kind of help reduce the site visits. So you're actually doing a lot of precision work, predictive work, or inspection, or just basically monitoring based off of that. So we will see that a digital cathodic protection element, it's going to change the technician's workflows, but also they're going to have to be very upskilled in knowing how to utilize intelligent technologies, also to analytics and things like that related to AI. One of the other areas too that I see is that the coating manufacturers, the coatings industry, I don't want to say coatings manufacturers, but the coatings industry is going to get to the point where we're going to have nano sensors that are within coating systems. So think of a buried pipeline system that has an ARO coating on it. That's a smart ARO. It protects it, but it transmits information that can be tied into a remote monitoring unit. So now think about the blending of having cathodic protection information and that coating system relaying data collectively together to the owner, or again whoever's monitoring that location and that site. Do you feel, or do you see that convergence, let's say, of smart coatings and smart cathodic protection mixed in with AI?
Yeah, for sure. I definitely think that's the way of the future. And there are a couple of breaks in the chain at this point in time, if I can call it that, because I think we've already built each of these as isolated pockets. It's the ability of marrying this with the right, as we said now, the workforce, the way and the direction that owners and asset owners are going to be working and operating within their systems. How do they manage data? How do they manage the information? Those are sort of the blockages right now. But I definitely think from a technology point of view, we have products available that can bring these solutions to the market. So to touch on a few of your points, like when it comes to digital rectifiers, rectifier technology has shifted and can easily be adopted to be more efficient, cleaner DC output, with the easy ability to be able to communicate with integrated remote monitoring systems. And with doing that, the amount of data and the clarity of the information that you can put into the cathodic protection system and the reporting, will definitely be improved. So we no longer need to use the old archaic type rectifiers, but able to actually move that technology forward to be able to clean and clarify that data. The thing is then is, again, to your point, is sensors. There are digital sensors, coupon sensors, corrosion probes. That kind of information can be actually utilized to control the rectifier, so that the rectifier can actually adjust itself to the data that is being sent from these sensors. So it's regulating itself throughout seasonal fluctuations or data in that specific environment. And so it can be now automated to operate at a certain level based on the data it's getting from its sensors, its electrodes, or its coupons. And so some of that technology is available. And then again, as it now has this data, that can be communicated back to a platform that an asset owner can hold and own and manage, or I think the other thing to what we're doing now with AI is putting that data into an AI sort of platform or a module or evaluation tool to actually look at analysis and say, what is this analysis? What is this telling me? What is the state of my system? And bringing that sort of full circle would be the next phase. And I think, again, that is where I think we're turning point now in 2026 and heading forward is how do I utilize this data? So if I put myself in the shoes of a young gun coming into the industry and saying, I want to step up and I want to make a mark in my business or my company or as an operator, these are the questions I want to ask and say, how do I up the technology? How do I get information that I can make proactive decisions by quick analysis of historical data rather than just sending a bunch of crews out there with trucks doing daily monitoring and filing my reports at the end of the month. And it's a very slow system, whereas we can actually still improve this. And at the end of the day, it's not taking anyone's jobs away because you're still going to have crews out there doing proactive maintenance or actually dealing with the troubleshooting areas because they'll be easy to find. You'll actually know where to go and when and why. And then handling that situation rather than just stopping along the road at every sort of mile marker and doing it the old school way. So there's going to be definite advantages going forward. And I guess to your point, Jim, is that there definitely is going to be a hybrid approach between cathodic protection system improvements and technology, the coating improvements, and then how do these work together? Because the coating is always going to be your primary form of defense on corrosion. That cathodic protection, I always say to people, it's like a insurance policy on that. But now knowing the state of the coating, if you had some nanotechnology onto that, knowing your cathodic protection, allowing the two systems to almost integrate into how the cathodic protection system reacts to the need of the coating failure, disbondment, whatever that situation might be. So now the two start working hand in hand, collaborating with each other because technology has led us to a point that these two can work together.
Yeah, and you really lead me into my next aspect of this is the integration with geographical information and also to asset management platforms. Because, like you were talking, now that related to, let's say, smart cathodic protection, smart coating systems, now you have the potential for a unified integrity data feed that can be fed into asset management platforms to be able to create faster decisions, maybe even be able to apply information or provide information regarding compliance for regulatory compliance or environmental compliance, whatever it might be. But also, too, when it comes to planning out projects as well, you'll be more proactive than reactive. And in worst case scenario, when you look at a buried pipeline, if it is something that is a critical pipeline, you don't want a catastrophic event. We've had those happen in the past. They're horrific for not only for the public, for the environment, but also too, they're very damaging for the industry. So the more information we have more readily available, that's more analyzed and more predictability we have, and the more focus we can have crews out there, the better we're going to be. Another area is materials and systems design innovations, because what we're seeing, and you can speak directly to this, is that we've got new cathodic protection technologies, anode systems, we've got improved, coating systems that can basically work in conjunction with cathodic protection. We're talking about shielding and non-shielding and things like that. But also too, I think what we're seeing is the emergence of hybrid cathodic protection systems. Am I far off on that aspect of the hybrid CP system?
No, not at all. I mean, I see a number of applications where we're looking at hybrid systems. You mentioned earlier anode technologies. There's anode technologies out there now where maybe in an old school way we would do a deep well ground bed, and in many cases now we're looking at linear anode systems, which work more in the same right of way. We have hybrid systems on a number of levels now that are starting to be integrated. But I think also to your point is, as technology changes, we have the ability to look at how we approach these projects. And the old school way typically has been to keep all my data, all my information to myself as the asset owner. But I definitely think that with congested right-of-ways, there's a lot of utilities that need to start looking at sharing that information between cathodic protections, the coatings, AC power lines, and how do these all work within and influence each other? And I think that if we can open up that conversation, it's going to be a lot more advantageous to all asset owners to know how they affect both positively and negatively each other, so that we can actually make engineering decisions and start improving the interference that we're starting to see. So GIS integration is one of those technologies. Another way that we can see us doing this is correlating committees is a hot topic. I know up in Pennsylvania there are correlating committees. We started a correlating committee down in the Southeast, and these correlating committees are then able to share information about where are the cathodic protection systems, how are they performing, how would they influence if I have, pipeline crossings, and if it's in my area, if it's not in my area. But at least having the access to some information that we can develop so that we know how we are protecting our infrastructure, not just by ourselves or with a specific asset owner, but more towards regional and area information. So I do think that that's a definite way that that correlation is going to start working and coming up, because we have data. How does the data work, and are we influencing each other in a positive way or a negative way? And if it's positive, it's good, let's share it. If it's negative, let's not hide it, but rather say, how do we improve on this or fix on this? And specifically because we have this influence on each other, we need to be having that conversation.
We really do. One area I want to talk about related to the coatings and cathodic protection relationship change in 2026, for me, one of the biggest is related to the Corrosion Technicians Association, the CTA. We're both founding members of CTA. Your company is a sponsor, thank you very much, of the CTA. And the big change that really kind of happened in 2026 for the industry is you have a newer organization that's emerging, it's growing, doing extremely well, related to the Corrosion Technicians, but also to the understanding of that both sides, the protective coatings and corrosion cathodic protection side, have to communicate, have to collaborate, have to become a community working together. Even though we might have separate interests, we all come together. Like I said, that one coin aspect of it. And what I found amazing with the working with the CTA, now we just launched a coatings committee, and we're looking at doing events. We're looking at doing training and certification. We're looking at working with the industry and with members and with companies like yours to really have a balanced approach, to take the aspect of coatings are very important, cathodic protection are very important, and together they can collaborate and even be stronger together. And so the CTA, I think, has really been a big change, I think, in 2026 to address a lot of the things that we've been just talking about. What are your thoughts about CTA, both a founding member and also a sponsor of the association?
Yeah, I really like what CTA is doing. I think that it's a great organization, and it's very timely that their founding is in the mainstream now. And so we're very proud to be somewhat affiliated with CTA. I guess the main exciting points for me about CTA is it's industry and technician focused. So it's about the people and saying, how do we share information on how we should be approaching our pipelines and protection of our industry. And it's from the ground up approach. So it's from people that are boots on the ground, sharing information and knowledge to say, this is the approaches that work. And it's gaining experiential leadership across technicians. And then it's regardless of whether I prefer, or my skill set is more in coatings or cathodic protection. The reality is our goal is to protect infrastructure. And if I might be more strong in cathodic protection, you're more in coatings. But now we have a tool that's going to bring us together to find standards, to find methodologies for testing. And as we look into that as a single library source, it's become a tool to bond us together. And then you're exactly and 100% right to say that then becomes the solutioneering approach that is going to be better than just focusing on a coating in isolation or cathodic protection in isolation. But now I have some skill sets, some information, some training that's going to bring these technicians that are in the field to a better solution. And I think the good thing about CDA as well is that it's going to push the industry forward in terms of new technologies, new products, and really is bringing together people that are active in our industry. So the reality is that the people that are pulling it forward are the ones that are current, that have communication, that are engaged and in touch with each other. And so I really like that movement. I think it's a great movement. Obviously, there are various industry platforms, training events, and online information. But really, I like the fact that it's upcoming, and it's really pushing this conversation forward, and that's part of what it's about. And so I like that, and want to be part of that.
Perfect, perfect. Let's now focus on what cathodic protections must watch. And I want to cover with you three emerging risks. Let me go ahead and I'll mention them and then we'll go through each of them. The first is AC interference in high voltage corridors. We talked about reconductoring. Stray current interference. And then the third is shielding effects and also hidden corrosion. When it comes to the AC interference in high voltage corridors, why is AC interference, why is it increasing, Aaron?
Yeah, so these are three hot topics, Jim. And AC interference is something that we're seeing on a very, very increased basis. So because we're building infrastructure, suburbs, cities, the right of ways in which assets and pipelines specifically are operating are all congested. They're becoming more congested. And so you have pipelines, power lines running in same servitudes or crossing each other. They may be perpendicular or parallel. And as this infrastructure moves across our cities, our suburbs, they're going to interfere with each other. And it's becoming more and more as we build and we develop our society. So that's why it's increasing. But as it's increasing, we're also increasing our demand on power consumption. So we're still lighting up our houses. We're now we're going to the point of AI, and AI needs faster internet, more electricity, more computer energy to operate and to have these data centers that are going to provide the technology to back up the AI. And those data centers are huge, not only consumers of electricity, but they're now part of their own electricity systems because that's how they're being built. So they're creating their own electricity in new locations that were not there before. And so they also have influence now on pipelines and buried pipelines. So the amount of influence is increasing, and the need for that is also increasing. And what's happening now is that the power line companies are reconductoring. So they're putting in larger and more higher capacity power lines. That power line system is going to increase the amount of influence on our pipelines, because we knew we had pipeline influence before at certain locations. That now is just scaled up, as well as the fact that these data centers are going to be new locations, putting in new influence in different areas. And that's only on top of the influence we already knew existed from the past few decades. So there are definitely some game changers at this point in time that are really scaling up the amount of AC interference that we're seeing on pipelines, and it's becoming more and more of a challenge. So yeah, definitely a very hot topic, and something that's going to be continuing for many years to come.
Yeah, definitely many years to come. When I first got involved on the coding side related to pipeline, I never realized this, and until a senior person pointed out to me. If you take the high voltage grid in the U.S., you take that map, and then you take the pipeline map, they're the same quarters. They all run. And then to your point, you've got pipelines that are next to each other, that crisscross, that are adjacent, very close, and there's a lot of pipe underground that's following the high voltage corridors. And as this increase in the reconductoring happens, it's going to cause some challenges out there. One of them is related to stray current. How big of an issue today and down the road here is stray current going to continue to be?
Well, it's going to definitely continue, and I think that the reality of that is that we have more energy now than we ever have in history before. Not only do we have that energy, but we are energizing different pipelines. Different asset owners are energizing their systems. We have the overhead utilities. We have various grounding systems. There's just a lot of energy out there, I guess, is the bottom line. It doesn't matter where it's coming from. It can be AC and DC influences. It can be from train lines. It can be from even what I've seen up in Georgia more recently is as we abandon our telephone line systems, what happens to those cables that were once buried telephone lines as we abandon that? Some of those may be shorting to ground. And so we have this energy and the stray current. To exacerbate that, our coating technologies are also getting more superior. And as that happens, it's insulating our pipelines more and more. And as it insulates the pipelines, our pipelines become well shielded, or not shielded is the right word, but protected from corrosion. But at the same time, it makes them more conductors because they're now insulating the pipe from the corrosion from the ground that it's intended to. But if I do pick up stray currents, it's now I'm able to energize and propagate that for further longer distances. And so that compounding effect may also apply. And so it's very important now that as we have these energy systems, stray currents and the AC interference, how do we collaborate with the coating and identifying the coating, the cathodic protection system, as well as my AC mitigation systems, to say, how do I bring these three trifactors together? So from my point of view as a cathodic protection person, I need to understand the properties of the coatings that I'm dealing with. I very recently even saw a pipeline that had been partially replaced. So we had an old section with older, very porous coating, sections with new, high quality coating. And I now had to cathodically protect the overall the fuller section with old and new coatings. And I actually had to then look at how do we treat these separately, because the CP demand on one does not equal CP demand on the other. And if I use a one size all approach, there's going to be further ramifications and the current doesn't disperse evenly. So that was an interesting situation. But then thirdly to that is this AC problem that we have and the mitigation strategies that we had to put into that, in that different pipe sections are going to be affected differently from that AC that was in that area and the stray currents. And so the mitigation approaches to bringing these three together is very tricky. But at the same time, it's something that we're now starting to deal with on a more, on a constant basis.
Yeah, I love it. The engineering approach, the fit for purpose, or where you have to do something completely different for the legacy coating system on that section of the pipeline versus the more newer coatings that are on a different section of it. That brings up really just to the third point, and it's dealing with, you talked about shielding effects, but also the hidden corrosion as we see more stray current, as we have grid high voltage lines upgraded with the no sag and more juice pushed through that, and we have an increase in basically electromagnetic and other type of issues that are going to arise. It really puts a stress on everything, and I think it goes back to the point of we have to have that balance of understanding, utilizing of but more advanced coating systems, of which could have the nano monitoring systems in it, but also the upgrades when it comes to the smart rectifiers and things like that. I think that's going to be so super critical. And I think you stressed the point on with that last project where you're going to have something a little bit more robust, because now you have one area that's going to be require a little bit more attention than the other part of the pipeline.
Yeah, that's exactly it. And so it's very hard to find a one size fits all approach. But as we sort of work out what each application needs, that intelligence and the information needs to be there so that we can make solid decisions, informed decisions, and then be able to adapt and say what is needed in this application, what is needed in this project, and then we can actually make educated choices and selection and engineering going forward from there. So it definitely is important to overcoming these challenges. And for the most part, again, the state of the cathodic protection in 2026 is there ready to say this is, to many cases, a turning point in our industry and in the way that we see things and our approach. And so I do see a tide shifting in terms of the technologies and the way that we implement and change specifications and our approach.
Yeah, and Jeff, I appreciate the comment here. I do agree that this is an area that we have to be able to address. It's not an us versus them. We're all focused really on one common outcome. We need to work better together. And, I think both sides, on the coatings industry side and the corrosion or cathodic protection side, we seem to have a lot of division over the years of, what's, how we both operate, and we never seem to have a lot of a collectivism when it comes to or shared mission and things like that. That's to the point when Aaron and I were talking about CTA. It's one of really the drivers with CTA is to focus on both aspects, cathodic protection and protective coatings, and focus on what the future looks like. And that's going to be both sides of that coin working together. So good. That's a good point, Jeff. Let's talk about the future of cathodic protection, where the industry is really heading. I know we've had some elements of talking about it. I think, Aaron, you and I do agree that we're seeing, and we will see more of predictive corrosion modeling. Is there any particular area more so, or maybe assets out there that make sense to have predictive corrosion modeling when it comes to the cathodic protection side?
Well, I think a lot of the times I see a lot of customers that don't have predictive monitoring or data collection. I think there's been a slow uptake across the board. I do think that remote monitoring needs to be something that's more embedded and pulled into the industry, and it needs to be seen more of. But I think the important thing is then taking that data and how do we use it? How do we leverage it for the improvements? So I guess the thing for me is I do see that we need technicians that need to have better information, better awareness, and then using that to move forward and be more proactive than reactive. I think that's the biggest thing. One of the other things I think I've seen a lot of people ask is where does AI fit into our industry? Is AI going to take our jobs? And those questions, while important, I don't see it being a downside or a negative. I actually see it being the upside. I actually see that it's going to take cathodic protection into a position or a way forward that we can actually go from this black magic kind of, voodoo kind of technology and engineering to actually saying, here is the data. You can now see it, and it's more tangible than ever before. And then now what do I do with this going forward? Because it's now become far more evident than before, where it was just like, I'm going to drop this anode in the ground and then hope for the best. And so I think that it's definitely going to drive us forward in terms of what we can do with cathodic protection and how we can actually pull that information forward. So artificial intelligence is definitely going to be one of those sort of industry's trends that I think is going to prioritize inspections and making recommended adjustments into the future. And it's going to take those experienced corrosion professionals forward. It's not going to hinder anybody. So I do like that's going to help us make better decisions going forward. And if we can integrate these data systems, with that remote monitoring to get good decision-making information, then for the most part, it's definitely going to take us forward.
Yeah, I mean, and you think of the smart rectifiers, AI in it, where it has certain protocols. If certain conditions are coming from the data, it can make micro adjustments. It can make adjustments versus waiting for someone to come in to the field to be able to make those adjustments. I think that's critical as well. Another aspect of it is, having a full integration when it comes to the integrity ecosystems out there. There are various type of data tools out there when it comes to integrity type of planning, monitoring, assessments, and things like that, to make sure that they're all working together. And you and I were talking about the aspect of, tying in, smart rectifiers, the RMUs, instead of just transmitting data, having a little bit more robustness built into them, including potentially the AI and other type of information. I think we're going to have to see an integration with that, especially if coatings start to go to the pathway of having, nano sensors in them to be able to do, current state of what the condition is of the coating system and things like that.
Yeah. So I guess to touch on that point, we have the rectifier technology now that it can control automatically. So it can adjust the output of that rectifier according to seasonal fluctuations, if it may be that, or it could be aging, as the coating deteriorates over, years and decades, it may adjust itself up periodically. But gone are the days where you have to go out and do manual tap change settings. That doesn't have to be that way. And so as you do that, the rectifier can automatically adjust itself. I think that's the good technology. The ability then to collect that data and see that graphing or those potentials over time would be very, very interesting to see. And then also, you don't have to have these huge incremental shifts in my protection criteria, because automatically it's going to be more of a linear type approach as it scales over years. And so pipelines might be more forgiving for that. But I've seen in tank applications where when I shift my one tap setting, I might go from underprotected to almost overprotected, whereas that kind of thing doesn't have to be there anymore either. So we're able to get far more finer adjustment and control criteria, improving that performance. And that ultimately, if I had to make that big adjustment, might decrease the lifespan of my anode. So it's ultimately going to also improve the lifespan for the design life of my cathodic protection system. But then again, to your point, is as we are able to now monitor these units remotely, it does allow us to know exactly when they're down, how long they're down, what their highs and lows would be. Perhaps there might be stray currents in that area, and a train line comes by at midnight, and every day at midnight I get this irregular reading. I can see that now on my remote monitoring side. But if I just went out there, daily or monthly or annually to do a single spot potential, it's not going to give me that same picture. So
Yeah.
I definitely think the field recommendation and tool sets that I recommend going forward is to do longer term data or potential profiling to see what happens in a 24-hour cycle or what happens ongoingly, so that I know the state of my cathodic protection throughout a daily 24-hour cycle, maybe a weekly cycle or a seasonal cycle. And I'll be able to actually see that data patterned out or graphed out or averaged out. But now I have the ability to have a ton of data, and I now also have the AI tools or the system potentially to analyze that and give me something that I can see. Okay, are we protected? Are we not protected? Are we overprotected? And where are we at the life cycle of performance on our CP system? So there's a lot that can be done with that. But at the same time, just skimming the surface, I definitely think that there's a lot of automation possibilities for us heading into the future.
It's a lot of great opportunities. And to close out the aspect of the future of CP, where the industry is heading, the big thing, and you alluded to it earlier, is related to the next generation of cathodic protection technicians. They're going to need to be upskilled, where you're moving away from the old school of analog cathodic protection to more of that digital, that new age, when you're dealing with artificial intelligence, you're dealing with smart systems and things like that. So the more, even things like just digital twins, can you imagine, working as a firm where you have a digital twin of an exact pipeline or some infrastructure, and you're going to be based off of what typical historical data is coming from that structure. You can mimic it in the digital platform to be able to deal with solutions, what fits the purpose best to solve a challenge or a situation. And then on the other aspect of working with the different systems out there, you're going to have to be a little bit more technologically savvy and things like that. So it's going to be a real interesting time. We know that the industry is going to continue to grow. It's not going to disappear. We do know that a lot of the infrastructure, we're going to continue to try to push those 50-year design life cycles to 150 years. USA just celebrated 250. And we got a lot of infrastructure that probably, there might be stuff in the ground that might be almost that old. I know in Pittsburgh, we do still have wooden water mains in some areas. So, we're over 100 plus years old. So, these things are going to obviously be important to deal with. But as a technician, what I'm saying is embrace the future. AI is not going to replace you. It's going to be a great opportunity for you. And the more you know about it, the more you can use that for opportunities to be marketable, the better off you're going to be. Any final thoughts on that, Aaron?
Yeah, no, I think that's very well said, Jim, and I 100% concur with what you're saying. I guess the only thing I would add is, we have the power now to do, various modeling softwares, and the modeling softwares allow us to predict what's going to happen with certain changes. designing solutions to what we're seeing in terms of the data that we can receive. And then as we do that, trying to look almost at predictive futuring of how it is that we're going to approach if we do take certain approaches. And as we do that, we're able to start seeing the influence. And the catch is and I've worked on some pipelines that are over 100 years old and performed really well with poor coatings, with variable CP, over the decades and years, and that have performed really well. And then you have new infrastructure that has done has struggled. But I think with the technology of having the ability to do modeling, to look at data collection, and the complexity of our environment with as we spoke about, the interference and stray currents, we're going to need all of that to be able to go into the next future and say, how do we predict this? What are the influences that we have? We're going to have to take more complex approach to how we design our corrosion mitigation systems or the integrity of our assets. And then as we consider all these factors and bring ourselves together from a coating side, cathodic protection, or just even integrity as a general concept, what does that look like going forward? It will be more complex, but I also strongly believe that it's going to be better.
It is going to be better. So everyone, takeaways from this conversation and Aaron and I have had is that cathodic protection, it's very strategic to integrity integrity assets that are out there. It's not a compliance checkbox. It's not, we got to have this and we check it off. The industry is definitely shifting from reactive to predictive. That's going to happen, and it is happening, and that technicians are really front and center for this transformation. They're super critical. Aaron, any final thoughts about what we talked about this afternoon?
Yeah, just a few, Jim. So I think the first one is that I've often heard that people think of cathodic protection as a black magic. And I think that with the technologies and the data collection opportunities that we have going forward, I think it's going to be more and more proven as a science where you see the effect, the effect, and you can make decisions on that. So I think that that's the first takeaway that I'm seeing shifting in people's mindsets into the future. The second thing is just around remote monitoring is pretty much going to become the standard and not as an optional feature. And what I've seen in the remote monitoring world is organizations are collecting data, but they don't necessarily know what to do with that data. And I think with the ability for us to now use AI tools, or as we get a more experienced workforce and experienced technicians, again, with assistance of a CTA or a correlation committee or some of the AMP chapters, as we work more together, I definitely see that the analysis of that data is going to be improved. And that's the key, is if you don't have the analysis, the data doesn't mean much. And then I think thirdly, I just think that we shouldn't just be collecting readings. A lot of that would be taken over a period of time, not just once a year, but more as from a regulatory point of view is ongoingly, how do we get more developed data and then being able to do predictive works on that, and that conversation with owners to say, where does the maintenance cycle go forward? Not just what am I doing on my capital expenditure and then it's a one and done, but rather how do we plan out the trajectory of our assets for an extended period of time?
Excellent. Aaron, how can people get connected to you? How can they find out information about what you do in your company?
Yeah, I appreciate that opportunity, Jim. So again, my name is Aaron. I work for CathTect USA. We're a cathodic protection specialist company, and we provide cathodic protection and corrosion solutions. We're based out in Florida, but our website is cathtectusa.com. You can also find me, Aaron Raath, on LinkedIn or CathTect USA on LinkedIn. And then if you need to get me by email or call, my email as well is my name, aaron@cathtect.com.
All right, Aaron, I'm going to put you in a hot seat right now. So yes, you and I have worked out, I want to say, I don't remember if we did 5 or we did 10, but let's say we did 5. We worked on a lot of potential future nooners that you and I could team up together. After this first one we just did today, you want to keep going on?
Yeah, I think it'd be great, Jim. I know that you did put out a few opportunity and topic discussions, and I think that they're great. I'm really excited to be part of that. And some of these topics are going to be really, really hot. So yeah, I'd like to be involved in it. And I think to your listeners, you've got some good stuff coming, and I like what I'm seeing. So good work to you, and I appreciate the opportunity, and I look forward to doing this again.
Yeah, we got good stuff, you and I, because it takes, again, two sides of that coin. And it's the same thing working with you, because I learned a lot from you. Like I say, when we were in Morgantown in May, we had a really good opportunity during that driving rainstorm to talk about a lot of topics, and I really learned a lot. All right, everyone. Thank you for this opportunity to have a conversation with you. I appreciate everyone who joined in. The one ask I have for you is to make sure you definitely hit the like. And then after this stream ends, please feel free to repost this, send the link for the event to a colleague or someone in the either industry, coatings or cathodic protection, that might find value out of listening, watching what Aaron and I have talked about today. Everyone, thank you so much. I really greatly appreciate all the support.